Section 4 is focusing mainly on finding the zeros of polynomials. So today there could be 2 answers, 3 answers, 5 answers. It depends on what the degree of the polynomial is. That'll really determine how we go about finding our answers. So we have 4 main objectives today. The first one is, I like to think of it as going backwards. If I give you the zeros, can you construct the polynomial? Now the other 3 objectives are going to go and kind of tie all together. They are going to build up to our end goal. This entire section is going to revolve around, can you solve polynomial equations? Can we find the solutions? So, if I give you the zeros, can you write me the polynomial they came from? Well, what do I mean by this? Let's look at this example. Find a 4th degree polynomial function. So this means by the time I get done, I know the highest exponent I should see is a 4. With real coefficients that has -2, 2, and I, so it has an imaginary answer, as zeros, and such that this is true. When I plug 3 in, I get -150 out. We will take this guy and deal with it last, so for now let's ignore it. So what I tell my students to do first with these, let's literally write down what they gave us. So they told me one of the answers was -2. So I'm going to write it like this. If I was solving, I would have got x equals -2. They told me another answer was 2. Great. They also told me I got an imaginary answer. Now, if you think back to when we dealt with imaginaries, whenever they showed up in equations, they showed up in pairs, just like square roots did. Because they came from having a negative under a square root. And chances are good if I was dealing with the square root, plus minus was involved. So the one catch you want to watch out for with these problems today, if you have an imaginary number involved, even if they only give you 1, it's understood that you also have its pair. So if you have the positive 1, you also have the -1 as an answer. And notice, if you think about it, it should make sense. How many things do I have written down? 1, 2, 3, 4. That's how I'm going to get the x to the 4th. If you forget the 4th one, you're not going to end up with x to the 4th at the end. So now what we're going to do is we're literally going to solve everything in reverse. Up until now, if we had done something, let's say, I don't know. Let's say I was factoring and I got to here, and then I said, hey, solve it. We would set each piece equal to 0, and we would solve. So I would get -3, and I would get 1. Well, we're going to do the reverse here. So if I got x equals -2, can you agree that that came from x plus 2? Right? If I set x plus 2 equal to 0 and solved, I would get x equals -2. So then the next one should have come from x minus 2. The next one should have come from x minus I. And the last one should have come from x plus I. I'm going in reverse. And technically, this is going to be equal to f of x. We're making this polynomial. Now, the only other thing I want you to add in, there could very well be some kind of a number sitting out front. Going back to the top here, when we were solving, if there would have been, let's say, a 5 there, well, if I set that equal to 0 and solve, I wouldn't have got anything from it. So the issue is, how do I know if there was a number sitting there or not? Well, that's where the part that I put in the rectangle is going to come into play. So for now, because we don't know for sure what this number could be, if there even is one, I'm going to call it A. We'll just use a placeholder. Okay, so now what we're going to do, we have it set up. Now we just have to clean it up. So I'm going to take f of x equal, I'm going to bring the a down for now, and your goal is to multiply all of this together. Now you can multiply this in any order that you want. What I highly recommend, because the math will be easy, let's FOIL these first two guys together first. So first times first, x squared. Outer, x times -2, -2x. Inner, 2 times x. And last times last, -4. Now, let's FOIL the back two guys together. So first times first, x squared. Outer times outer, I times x, I'm just going to write it as ix. Inner times inner, -I times x, I'm going to write as -ix. And now be really careful with last times last. -I times I would be -I squared. Okay, let's clean it up even further. So f of x equals, just bring down that a for now, combine like terms, and I should get x squared minus 4. The two x's canceled. If I combine like terms in the other guy, the ix's cancel. Now remember what I told you I squared was equal to. I squared is -1. But there's a negative in front of it. So the two negatives would actually make it become +1. Okay? I am going to FOIL these together again. So f of x equals, keep the a. So first times first would be x to the 4th. Look at that. There is that 4th appearing that we wanted to see. Outer times outer, x squared times 1 would be 1x squared. Inner times inner, -4 times x squared, -4x squared. And last times last, -4 times 1, -4. Combine like terms. 1x squared minus 4x squared would be -3x squared. Okay, the last step, yeah, this is kind of a doozy problem, which is why I think I only gave you like 74 of them, it's fine, is to find a. I want to know, what is this mystery number? So this is where we're finally going to return to that last piece of information they gave me. They said f of 3 equals -150. So all this means is when x was 3, y was -150. That's what that means. When I plugged 3 in, I got -150 out. So what we're going to do is we're going to put -150 in for my y. Remember, f of x is y. I'm going to leave a alone. And what do you think I'm going to put in for x? The 3. And now I'm going to simplify it. So if I do this simplifying in parentheses, which I'd be fine if you put that into the calculator, if we combined all of that together, it should be 50. I'm going to rewrite that just to make it a little more user-friendly. I'm going to say 50a. So then the last step to solve for a would be to divide by 50 to undo that multiplying. So a equals -3. That's my mystery number. So, hallelujah, we are almost done. The end polynomial, my answer, would be -3, and then x to the 4th minus 3x squared minus 4. I would be okay if you left it like that. Now, I'm not sure on my math lab. They might want you to distribute, so you could also write the answer in this form as well if you distributed. So This isn't necessarily a difficult problem, there's just a lot of steps to it. The main focus today is going to be solving polynomials, and that's what the rest of the notes are going to build up to. So to help solve polynomials, because unfortunately not all polynomials can be factored. If they can be factored, then that's the way I want you to do it, because that's quick and easy to solve. But not all of them will factor. So there is another way, and this way will always work. It's called the rational zero theorem. There is that word again, rational, which means they can be written as fractions. So what this rule can be used to do, it can be used to list, and I want you to write this word in capital letters. It can be used to list the possible rational zeros. I cannot stress enough this word possible. And I'll tell you why in just a moment, but that's a key word. These are possible answers. So if they are possible answers, that does not mean all of them will be answers. It's a possibility. So if I have a polynomial in this form, let's say, well, in the polynomial form that we talked about at the start of this chapter. So then we had the next term plus dot 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 a1x to the first plus. So the really scary form of a polynomial. But remember, all this means is I start with my highest exponent, and then I just work my way down in decreasing order until I get to the term that doesn't have any variables with it. That's a polynomial. So if we have something in that form, I want you to think in terms of P and Q. Now, why did they use these two letters? I honestly don't know why they picked P and Q. It's just the letters they decided to go with. P is going to represent all of the factors of the last guy, the constant. So this guy, the guy without any variables. Q is going to represent all of the factors of a sub n, which is the leading coefficient. What do I mean by that? Well, I mean it's going to be this guy, the leader. So then what this rule says, to get my possible zeros, to make my list, once I have P and Q identified, all I do is I take P divided by Q, and that's going to make my list of possibilities. This is essentially coming from a method of factoring, but not quite. Let's put some numbers with this so you can see what I mean, because it really doesn't make sense until you see it with an example. List all the possible rational zeros. There's that word, possible. Then determine which, if any, are zeros. So, let's first make sure, is this written in standard form? Is it written in decreasing order of the exponents? Yes, it is. That's going to be important. The next thing I would like you to do is we're going to make ourselves a list. We are going to identify P and Q. So P is all the factors of the constant. Well, in this one, what is the constant? It's 8. So P is not 8. I want to know all the factors of 8, all the things that multiply to 8. So you might say 1 times 8, and I would say yes, except we're going to use plus minus, because do you agree that 1 times 8 is 8, but negative 1 times negative 8 is also 8. So we have to include the negatives. Okay, what else multiplies to 8? 2 and 4. So plus minus 2 and plus minus 4. So those are all of the factors of P. Nothing else multiplies to 8. Q is going to represent all of the factors of my leading coefficient. Here's the leader. So all the things that multiply to 3. Well, it's only 1 and 3, but we're going to say plus minus 1 and plus minus 3. That's half the battle right there. So now I am ready to make my list of possible zeros. I'm going to make this word big again. So my possible zeros, all I'm going to do is I'm going to take P divided by Q. So here's the easiest way that I think would make the most sense. I'm going to take all of the P's and divide them by the first Q. So 1 divided by 1, plus minus 1. 2 divided by 1, plus minus 2. 4 divided by 1, plus minus 4. 8 divided by 1, plus minus 8. So that was all the P's divided by 1. But there's another Q. So I'm going to do it again. 1 divided by 3, plus minus 1/3. 2 divided by 3, plus minus 2/3. 4 divided by 3, and 8 divided by 3. So I'm taking all the P's divided by all the Q's. I don't really care what order you write them in. So be careful, because if I asked you, okay, here's my possibilities, how many numbers have I written down? If you tell me 8 numbers, you're wrong. There's actually 16 numbers up here, because the plus minus. Now on my math lab, when you enter these, I think what you'll have to do, because there's not a plus minus button, you're going to have to type them in like this, which is going to be a pain. I'm not going to list them all, but you're going to have to type them separately. So now the question is, determine which, if any, are the zeros. Well, my first question would be then, if I were to solve this polynomial, how many answers should I be expecting? Remember, this is where we look at the highest exponent. Since it's a 3, I should have 3 answers. Now, hold up. 3 answers? There are 16 answers here. No. Goes back to this word. These are 16 possible answers. According to this, only 3 of them will actually work. So not all 16 are going to be answers. Only 3 of them will work. So what's the purpose of writing these out? Well, it narrows down my search. Rather than blindly guessing, I now at least have a window. I know what to check. Now on this one, I'll tell you that the 3 answers are these 3 numbers. And hopefully you agree that these 3 numbers were in my list. They were all in that list somewhere. But now the question is, okay, how did I get those? How did I know that those 3 things were the answers? That's what I want to do on the next example. I want to show you how do we figure out from our list what are the actual answers, because they're not all answers. So let's look at the next example. We have something in math called the fundamental theorem of algebra. It is a big fancy title for something that is not fancy, and you already know this. All it says is a polynomial of degree n has that many zeros. So if the highest exponent is a 5, I'm going to have 5 answers. If the highest exponent is a 2, I'm going to have 2 answers. That's all this is. So here we go. Find all the zeros of the function. My first question would be, how many answers should I have at the very end? You should tell me there's going to be 5 of them. So I know there's going to be 5 zeros. So now I have to find these 5 numbers. So to help narrow down our search, I want us to do the same exact thing we did on the previous problem. Let's make a list of possibilities. So what's P? Well, it's the constant, the 30. So I want all the factors that multiply to 30. Let's start with 1. 1 times what is 30? Well, 1 and 30. Now there's a reason. You'll notice when I do these, I always start on the very ends, the 1 and the 30, and then I leave space in the middle. I like to work my way in so that I don't miss any factors. Does 2 go into 30? Yes, 2 times 15. Does 3 go into 30? Yes, 3 and 10. Does 4 go into 30? No. Does 5? Yes, 5 and 6. Notice by working my way in, I close the gap. I know I'm done because there's no whole numbers between 5 and 6. So I know I found them all. I don't care if you do it that way. It's just a way to make sure you don't miss anything. And now let's do Q, all the factors of the leading coefficient. Well, what is that number? It's a 1. Well, the only thing that multiplies to 1 is plus minus 1. So now my possibilities, these could very well be the answers somewhere in this list. I have to take all the p's divided by all the q's. So 1 divided by 1, 2 divided by 1, 3 divided by 1, 5 divided by 1, 6 divided by 1, 10 divided by 1, 15 divided by 1, and 30 divided by 1. So there are my possibilities. Now we're actually going to see, can we get the 5 answers from this list? So the question is, how do we get those answers? Because I just magically made them appear on the last example. I'm going to apologize now. Out of all the lessons we do this semester, this one will probably be the biggest pain in the butt. If you can get through this, you can get through anything. It kind of depends on how good of a guesser you are. So here's what we're going to do. We are going to use synthetic division from the last lesson to help us with this. So I want you to set up the synthetic division box. And inside the box, we are going to put our lovely polynomial. So remember, we take the coefficients, so 1. Now careful, notice they have skipped the x to the 4th term. It's gone. You have to use a 0 or it's not going to come out right. And then the negative 18, and then the 30, and then the negative 19, and then 30. Okay, so now the question is, what do we put out front? Well, this is where it's up to you. You want to pick one of these numbers and test it. So I'm going to say a good hint, because you might say, well, geez, that could take forever. It could. I would start on the low end, because chances are good, usually one of those is an answer. I'm going to start with 2. I'm going to check a positive 2. Let's see what happens. So we bring down the first guy, drop it like it's hot. 2 times 1, 2. Then we add them. Then we multiply, 2 times 2. Then we add them. Then we multiply. Then I add them. Then I multiply. Then I add them. Then I multiply. The key to knowing if the number you checked, so this 2, the key to knowing if it is one of the 5 answers is in the remainder. We got a remainder of 0. That means it's an answer, because that means it divides in cleanly. It's a factor. So I have just found one of my answers. X equals 2 is an answer. If I wouldn't have got 0 out, it'd be back to the drawing board. That means that number is not an answer. So now let's pick another one. I'm going to cheat just to save time for the purposes of this video. Let's check 3. Now notice, when I check the next one, just pick right up where you left off. It will work if it's an answer. You don't have to start over. Just pick right up and use your previous answer, as long as you got 0 out. So bring the first guy down, multiply, add, multiply, add, multiply, add, multiply, add. Oh, I got 0 out again. So that means 3 is an answer. So I'm going to add that to my list. There's answer number 2. I'm looking for 5, so we got to keep going. Let's go again. I'm going to tell you, just because I already know this and to save time, let's try -5. Don't forget when you check these, try the negatives as well. Don't forget that the negative versions are options. So bring first guy down, multiply, add, multiply, add, multiply, add. Ding, 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 I got a remainder of 0 out, so -5 is an answer. Now, I'm going to tell you, if you were to check the other numbers, none of them will work. Well, what the heck? If none of my other possibilities will work, but I need 5 answers, where are the other 2 answers at? Because I need 5 and I only have 3. Well, here's what I recommend. Let's write this result down here back as a polynomial. So let's think about it. It was originally x to the 5th, and I've divided how many times? I've divided 3 times. So when I write this back as a polynomial, this will now be 1x squared, because I divided 3 times, plus 0x plus 1. That's the polynomial. So I would actually just say x squared plus 1. I wouldn't write the 0x. Once it's down to its quadratic form, the highest exponent is a 2, let's just solve it to get the other answers. So if I set it equal to 0, how would I solve this? Well, I would subtract 1 over, and then what would we have to do? To get rid of the square, we would have to square root. Hopefully you're yelling at me. Plus minus is going to appear. And what is the square root of -1? It's I. There are the other 2 answers. So if I listed all my answers, my final result, I'd have 2, I'd have 3, I'd have -5, I'd have positive 1i, and I'd have -1i. That's why those other 2 answers weren't going to show up in your list. They were imaginary. Oof. You might be thinking this assignment is going to take forever. Oh, probably only like 4 days. It's fine. No, I'm kidding. I am not going to make this assignment super long because I know that this could be a trial and error process. Let's try another one though. I want to make sure we have this down. So you might look at this and go, well, wait, there's 4 terms. Let's just group it. I'll tell you it won't group. You won't be able to get your groups to match. But that is a good thing to spot if you spot that, because if you can factor it right away, do that. That's much quicker, much quicker than the P and Q method. Unfortunately, we're going to have to do the P and Q method. So P, all the factors of the constant. So 1 and 8, 2 and 4, and that's it. Make sure you have plus minus. Q represents all of the factors of the leading coefficient, which is a 1, so plus minus 1. Now we are ready to list our possible answers. And actually, I didn't ask this first. How many answers will I be expecting by the end? There's going to be 4 answers on this problem. That's my goal. So my possibilities, I want to take all the P's divided by all the Q's. So 1 divided by 1, 2 divided by 1, 4 divided by 1, and 8 divided by 1. So there's my list. All right. Let's see. So I want to show you what happens if you don't pick a good one. So let's say I was going to start this, and let's set it up. Did they skip anything? They did. So I have my 1. I have my negative 3. I have my negative 12, but then I should have a 0 because they skipped the x to the first, and then 8. If you miss that 0, it's going to screw up the math. Okay, from my pink list here, I have to pick one of them. Let's say I want to try 1. I think 1 is going to work. Watch what happens. Bring the first guy down, multiply, add, multiply, add, multiply. It's at this point, I wouldn't even finish it because kind of looking ahead, my remainder is not going to come out to 0. So I would either cross it off, I'm just going to start over. No good, that was a dead end. Let's try negative 1. And again, it was 1, negative 3, negative 12, 0, and 8. So bring the 1 down, multiply, add, multiply, add, multiply, add, multiply, add. Okay, I got a remainder of 0. So yes, I'm going to make myself a note. Here's one of my answers. Negative 1 is an answer. We're going to go again. What else to try? Well, to save time, I'm going to tell you that the next one is negative 2. So bring down the 1, multiply, add, multiply, add, multiply, add, ding, 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 remainder of 0. So let's add that to my list. Negative 2 is another answer. Now it's at this point where I would not check anymore. And you might say, but wait, there's 4 answers. Well, when you get to the point where there's only 2 answers left, let's write our result back as a polynomial and just solve it that way. So originally it was x to the 4th, and I divided how many times? 2. So as a polynomial, this will now be x squared minus 6x plus 4. To get the last 2 answers, we're just going to solve this. So I'm going to set it equal to 0, and we're going to solve. So my choices are I can factor it, I can use the quadratic formula, complete the square. Sad news, I would want to multiply to 4 and add to negative 6. It's not going to factor. So I'm going to have to use the quadratic formula. Oh, what's that? You forgot the song? Well, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. I'm in the library in a room right now recording this, and I am getting some looks. That's okay, judge away. So, it's been a while since we've used this guy. This is a 4. Let's identify a, b, and c. So remember a, 1, b, negative 6, c, 4. Substitute in. So a negative b, since it's already negative, it's going to turn positive. Plus minus negative 6 squared. Make sure you have those parentheses, especially since it's negative. 1, 4, all over 2 times 1. Okay, we just got to clean it up and we'll have them. So 6 plus minus negative 6 squared, 36, minus 16, 4 times 1 times 4, all over 2, square root 20. And now I want to simplify that square root, please. 20 is not a perfect square, but there's a perfect square that will go into 20. And you should say, oh, it's 4 and 5. So really we could just say 2 square root 5. And if you remember when we did the quadratic formula problems, there's one other thing you could do. Because I can do it from all three, I'm going to divide everything by 2. So I get 3 plus or minus 1 square root 5, and there they are. So if I asked you to write me the 4 answers, we would say -1, -2, 3 plus square root 5, and 3 minus square root 5. There are the 4 solutions. Okay, and the last example I'm actually throwing out, we're not going to do, it's just another of the same type. Basically, this lesson boils down to, can you synthetic divide? If you can do that, then it's just a matter of kind of guess and check. And I promise the assignment won't be monstrous.